Thermodynamic. The term thermodynamic refers to a branch of physics that deals with the relationships between heat, work, and energy. It focuses on the study of how energy is transferred and transformed within systems. In thermodynamics, there are several key concepts that help us understand the behavior of energy. Let's explore some of these concepts with examples. 1. System and surroundings. In thermodynamics, we often consider a specific portion of the universe called a system, and everything else outside it as the surroundings. For example, if we are studying the behavior of water in a closed container, the water and the container would be the system, while the air and everything else outside the container would be the surroundings. 2. Energy. Thermodynamics revolves around the concept of energy, which can exist in various forms such as heat, work, and internal energy. Heat refers to the transfer of energy due to temperature differences, while work is the transfer of energy due to mechanical processes. Internal energy is the sum of the microscopic energy of the particles within a system. 3. Laws of thermodynamics. There are 3 fundamental laws of thermodynamics that govern the behavior of energy. The first law of thermodynamics, also known as the law of conservation of energy, states that energy cannot be created or destroyed, only transferred or transformed. For example, if we heat a pot of water on a stove, the energy from the stove is transferred to the water, resulting in an increase in its temperature. The second law of thermodynamics states that the total entropy, a measure of disorder, of an isolated system always increases over time. This law helps explain why certain processes are irreversible. For instance, when you mix hot and cold water together, the resulting mixture will eventually reach a uniform temperature, but it will not spontaneously separate back into hot and cold regions. The third law of thermodynamics states that as the temperature approaches absolute zero, 0 Kelvin or minus 273.15 degrees Celsius, the entropy of a pure crystalline substance approaches zero. This law provides insights into the behavior of matter at extremely low temperatures. 4. Thermodynamic processes. Thermodynamics also describes different types of processes that systems can undergo. Some common processes include isothermal process, a process that occurs at a constant temperature. For example, when a gas expands in a container and heat is added to maintain a constant temperature. Adiabatic process, a process that occurs without the transfer of heat. For instance, when gas is compressed rapidly, preventing any heat exchange with the surroundings. Isobaric process, a process that occurs at a constant pressure. An example would be heating a liquid in a pot at a constant pressure. Isochoric process, a process that occurs at a constant volume. For instance, when a gas is heated in a sealed container, and no volume change occurs. These are just a few examples to give you an understanding of the term thermodynamic and its usage. Thermodynamics plays a crucial role in various fields, including engineering, chemistry, and environmental science, helping us understand and predict the behavior of energy in different systems.